Hello everyone. Today we are going to see the concept that is the modes of operational amplifier. Why the op amp is having modes. So in the previous video we have seen how to draw the transfer characteristics of operational amplifier. So we know that the transfer characteristics is nothing but a plot between output voltage and input voltage, but here the operational amplifier is having minimum two number of inputs, so that's why we are considering a differential voltage. So finally the transfer curve is nothing but a curve plotted between output versus in differential input voltage. And here we have seen how the curves of ideal op amp and practical op amp looks like. So depending on that, the operational amplifier is having two modes. One mode is a open loop mode and second one is a closed loop mode. Now what is the difference between open loop mode and the closed loop mode we are seeing in the next slides. So here, if you consider the open loop mode, in this mode the op amp is simply acting as a switch, means it has to pass the signal or it has to block the signal. That is the switching operation we know. But here, depending on the input signal voltage, the op amp output voltage value will be fixed. Either it will be a plus Vsat or either it will be a minus Vsat. Here the saturation values is nothing but the power signals applied to the op amp pin terminals. Okay, and here this positive and negative sign will depend only on the magnitude of differential voltage. This open loop op amp will act as a switch. So in some applications, if I consider, if you want to compare two signals, then this open loop mode will be useful. Okay, but in not in all applications we cannot use the op amp in open loop mode. For example, if I consider an amplifier application, if the op amp is operated as amplifier and that too in open loop mode, then this case is not possible. Why? Because what the amplifier will do, it should have to amplify the input signal or strengthen the input signal. If I given the input signal as a sinusoidal signal to the op amp, the output signal should be an amplified version of a sinusoidal signal. But here, if you consider in the open loop mode, if I give the input signal as a sine signal to the op amp, then the output of an open loop op amp is a square signal or a pulse signal. So in the case of amplifier, this open loop op amp is not useful. Now what is the other method? So open loop and the next we are preferring closed loop. So as in the electronic circuits we have seen so many differences between open loop and closed loop. So here a closed loop is nothing but a feedback path is present from output to the input. Okay, some portion of output signal is added to the input signal. Now again here we are having a two types of closed loop. One is a positive closed loop and second one is a negative feedback closed loop. If you are considering an oscillation application, then the op amp is used in positive feedback closed loop. Okay, if you are concentrating on amplifier application, then the op amp should be used in negative feedback closed loop. So depending on the application you can choose any of the op amp. And here in the closed loop application, the op amp is operating in a linear mode. Now in the next video we are going to see what are the closed loop applications and how the closed loop circuits will be there. And further we are going to see what is a open loop in deep and what are the applications of an open loop. Okay, so let us see what is the open loop configuration of op amp. So here I am considering a practical op amp. So from this graph you can see that the range of a practical op amp is reduced, means it is in between plus or minus 75 microvolts. Between this range only the op amp will work in the linear region, means there is a restriction of differential input voltage value in order to operate in linear region. Otherwise the op amp will go into the saturation, means with the small range in differential input value the op amp will act as a small signal amplifier in the open loop mode. Okay, and now Next, see the application. So in the open loop mode, the op amp is applied as a comparator circuit or a zero crossing detector. So in the open loop, we know that there is no feedback present from the output to the input. So the open loop op amp is a high gain amplifier. As we know that the op amp itself has a infinite gain ideally, and practically its value is very high. So we can say that in this open loop configuration, the op amp will work as a high gain amplifier. Now we are going to see what are the applications of an op amp. So the op amp is having three modes in open loop configuration. One is a differential amplifier, second one is an inverting amplifier, and third one is a non-inverting amplifier. Okay, so if you observe in the differential amplifier, this is the circuit, but practically we are not using this circuit. Why? Because we know that the output voltage of an op amp which operates in open loop mode is either plus VCC or minus VEE. Just it's an introduction only how the circuit will be. So here the op amp is having two input signals, non-inverting terminal and inverting terminal. So to this two input signal sources were applied, V in 1 and V in 2, through the series resistance. Okay, so here the differential amplifier means here the output voltage must be amplified version of difference of two input signals. It is a standard equation we are writing, but in practical we are not using this open loop mode of differential amplifier. Why? Because here this output voltage V0 value is a fixed value. Okay, next see how the inverting terminal amplifier circuit will be. So inverting amplifier, so if you observe, this is the circuit of inverting amplifier of op amp in open loop mode. So here the input signal is applied to the inverting terminal of op amp. That's why it is called as an inverting amplifier. Since the input is applied to inverting terminal, we know that the basic output voltage equation V0 is gain into input voltage. Okay, so here the gain of an op amp in open loop is AOL, and the input voltage we are considering as a differential voltage VD. So this differential voltage VD is nothing but the difference of two input signals. So V1 and V2. Here V1 is grounded, so it is 0 minus V2. So finally the output voltage V0 is minus AOL into V into. Okay, and here the graph looks like it's simply a sine wave. I replicated the input signal, but here the negative sign indicates that 180 degrees phase shift will be provided, but in practical we are getting only the pulse signal or a square signal, either plus VSAT or minus VSAT. Okay, it just represents the negative sign. In order to identify what is the negative sign represents, I just draw the replica of a input signal at the output. Okay, now let's see last one, that is a non-inverting amplifier mode. So in the non-inverting amplifier mode, we can say that the op amp is working non-inverting amplifier if the input signal is applied to the non-inverting terminal of op amp. Okay, so again the same procedure. So in order to obtain the V0 expression, there it is AOL into VD. So here VD is nothing but difference of two input voltages V1 minus V2. Since here V2 value is grounded, so finally it is AOL into V1. And if I observe, it means that it is a plus sign indicated. It means there is no phase shift present in the non-inverting amplifier, or a 0 or 360 degrees phase shift will be present between the input signal and the output signal. Whereas in inverting amplifier circuit, here a 180 degrees phase shift will present between the output and the input signal. Okay, so these three circuits like differential amplifier, inverting amplifier and non-inverting amplifier circuits are not practically used if you consider the op amp in open loop mode. Why? Because here the output signal is a square signal or a pulse signal. That's why we are not preferring these three modes of open loop op amp in practical applications. Thank you.